All right, let's go over this mixtures versus pure substance worksheet that you guys did yesterday. You were to identify each material as either a mixture or a pure substance, and then if it was a substance, you had to decide if it was an element or a compound. If it was a mixture, then either homogeneous or heterogeneous. Okay? All right, so let's go through it. Um, First one was aluminum foil. That was a substance. It is one type of atom, aluminum, rolled into a like foil or sheet. So since it's only one type of atom, it's considered an element. So let me show you that on the periodic table. So here are the periodic table of elements. There's a lot of them. And if we find that particular name, aluminum, on the periodic table of elements, then it is a substance, a pure substance with just one kind of atom. So here it is, number 13 on the periodic table. So all of the atoms in aluminum foil are just aluminum. That's it, one kind of atom. So that's what makes it an element. The next one is air. Air is a mixture. It's homogeneous. This means that it is uniform throughout. It's a mixture because it's made up of many types of gases. And the gases that make up air, sure, those are substances. But when they're mixed together in the air, in the atmosphere, it's a mixture. So our atmosphere is made up of more than one kind of element or compound or substance. So air is a mixture. Soil. Soil is considered a mixture. We can usually see all the different pieces of the soil. Sometimes soil can be considered homogeneous if it is uh, more uniform throughout. But if you actually took a magnifying glass up to it, you would see the different elements, the different pieces of the soil. So we're going to call that heterogeneous. Water is a substance. So let's talk about that. Aluminum foil was a substance and it was an element. Water is something different. It's a substance, but it's not on the periodic table of elements, but it's made up of two types of atoms that are on the periodic table of elements. And those atoms are chemically combined, which means that they're more attached. They are attached to each other. So if we look at the periodic table of elements, we will not find H2O, which is the chemical compound for water, but we will find what makes up water, oxygen and hydrogen. So when those two elements are combined to make water, it's a compound, okay? So a substance. Steel, this is a mixture of different kinds of metals. So again, on the periodic table, we're not going to find steel. You could search and search and search and search, and you won't find the steel mixture. But you will find different things that make up steel, like iron, which is in steel. Okay? So it's a bunch of different metals mixed together. They are not chemically combined. It is uniform throughout. We cannot see the different types of metals in there. They're evenly mixed. So it's homogeneous. M&Ms is a mixture. Even a single M&M is a mixture. The bag of M&Ms, you've got the different colors, right? That makes it heterogeneous. Even a single M&M is heterogeneous. You have the shell, you have the chocolate. So you don't have uniform mixed throughout. Sugar, this is a substance. Okay? It is a compound. You won't find sugar on the periodic table, but you will find the elements that are chemically combined, connected to make up sugar. So sugar is carbon, and it is oxygen, and it is hydrogen. So I've always said C6H12O6, and the numbers just mean how many carbons. 6 carbons. How many hydrogens? 12 hydrogens. How many oxygens? 6 oxygens in the single molecule. So they are chemically combined. That makes them a compound. Sugar water. Now this is when we take sugar and we pour it into water, and the sugar will dissolve. It still is a mixture. The sugar does not chemically combine with the water. The sugar just kind of nestles their way into the spaces of the water molecules. So you've got the sugar water molecules just really sitting next to water molecules, but not attached. They're not attached. They're just sitting near water molecules. That makes them a mixture. And this is uniform throughout. Pizza is a mixture. You can see all the different parts of the pizza. Okay. Blood is a mixture. You cannot see all the different parts of blood. It is uniform throughout. So that makes it homogeneous. Table salt. This is an edible thing, something that you pour on your French fries. It is a substance. Again, on the periodic table, we won't find salt as an element, but we will find it's things that make up the salt that are chemically combined. That means that the elements are attached to each other. So sodium over here, chlorine atoms over here. I actually have what that molecule looks like. So this is sodium chloride. This is sodium atoms attached to chlorine atoms, and it makes this crystal-like structure that have our atoms, but notice that they are attached to each other. That makes it a compound. That makes it a pure substance. Iron fillings. Iron fillings are just pieces of iron that have been filed down into small, tiny like flakes. Filings, fillings, filings. But that is an element. Oops, sorry. Substance first. Then it is an element. It is on the periodic table. Doesn't matter what form it's in, whether it's part of a bar of iron or it's a filing, like filed down into smaller pieces. It is on the periodic table, and it is iron. Okay, right here. Gasoline. That's a mixture. It is made up of many different kinds of compounds. Okay, it is homogeneous. So it's a mixture of a bunch of different chemicals, and they aren't chemically combined. They're mixed together. Coffee. Okay, so if you were questioning, is this just coffee beans? Was this a cup of coffee? It was really a cup of coffee. So that would make it a mixture because you've got it mixed in with water. And coffee would be, a cup of coffee would be homogeneous. Okay. Orange juice, that is a mixture. Even pure orange juice, like coming straight from an orange and then you drink it, it's still a mixture because you've got the pieces of the orange, you have the sugar part of the orange and the water, a lot of water, you have acetic acid. So you've got different things that make up oranges. But orange juice is also a mixture, and it is uniform throughout. Now, I'm talking about the non-pulp orange juice. I guess if you had more pulp like orange juice, it could be heterogeneous. Cannot seem to spell that. All right, pencil lead. So pencil lead, a long time ago, was made out of actual lead. Let's see if I can find lead on the periodic table. It's kind of hard. There it is, right there. Lead. Okay, so it's an element. But nowadays, pencils are made of something called graphite, which is like compressed kind of or processed kind of carbon, which is on the periodic table. So carbon is an element as well. So whether it was pencil lead from 40 years ago, 50 years ago, 60 years ago, or pencil lead that is made out of graphite, it's still an element. It is a substance, then an element. Okay, copper, something on the periodic table, a metal. There it is. So that makes it a substance, and that makes it an element, one kind of atom. Bronze, you won't find bronze on the periodic table. It's a blend of metals. So that makes it a mixture. And it is homogeneous. Milk and cereal. You've got the milk, you've got the cereal, you've combined them, mixed them. That is a mixture. You can see the different parts of the cereal, and you can see the milk. Heterogeneous. Acetic acid is a substance. It's a compound. You won't find it on the periodic table, but it is a chemically combined. So the atoms, the elements are chemically combined to make the acetic acid. So that makes it a compound. Okay. I know that this third column was more of a stretch, so I hope you tried to challenge yourself a little bit. You will not have to do this part, the third column, on the quiz. You are just going to have to decide if the material is a substance or a mixture. Okay. All of the items on the quiz are things that are either in this sheet or in the slideshow the video that I did yesterday. You'll find all of these things on the quiz. So use these as your study guide. Make sure that you know sugar is a substance. Sugar water is a mixture. Blood is a mixture. Table salt or just salt is a substance. So, kind of quiz yourself, test yourself. Go through the PowerPoint again, the Google slideshow, which is the video, but you guys have access to just the Google slideshow if you want to review all of the examples there as well. Okay. One thing I wanted to clarify, the difference between baking soda and baking powder. So there might be some confusion on these two things. They are two different things that are used in baking. Okay. Baking soda is just sodium bicarbonate. That is a molecule. So that is a compound made up of sodium atoms and carbon atoms and oxygen atoms, all chemically combined. So it is a substance. So one way to remember that baking soda is a substance is look at the S. Okay, baking soda, S, substance. Whereas baking powder is made up of sodium bicarbonate and other ingredients. So when it says plus an acidifying agent and a drying agent, well, you've got more ingredients there. That makes it a mixture. So baking soda, one molecule, one compound, substance, there's that S. Baking powder, which is a compound. So I just wanted to clarify that. Okay? All right. Let me know if you have any questions through email, or you can send me a private message through Google Classroom. Go ahead and turn this in. Once you've gone over it and you fixed your answers, you can turn it in. Okay. Also, you also have an assignment in Google Classroom, and this is just a Kahoot that you can use to practice. Okay. I've also uploaded a practice quiz. So take the practice quiz, see how you do. If you get 100% on the practice quiz, you still have to take the quiz tomorrow. All right, so you're just practicing today. But yes, you still have to take the actual quiz tomorrow, even if you get 100% on the practice quiz today. All right, see you later. Have a good day.